Welcome, wherever you are right now, whatever the hour, whatever the weight of the day you are setting down. You are here, and the universe is waiting for you. This channel exists for one purpose: to carry you gently away from the noise of the world and into the deep, luminous quiet of space. These are long journeys, hours of slow, unhurried narration, drifting through stellar nurseries and ancient light, through the soft architecture of nebulae and the patient lives of stars. There is nothing to do here but rest and breathe and let the cosmos hold you for a while. Every video on this channel is crafted with care, written to feel like a single, seamless voyage rather than a collection of facts, each sentence shaped to carry you a little further from wakefulness and a little closer to sleep. Whether you are visiting for the first time tonight, or whether you have drifted through one of these journeys before and found your way back, you are warmly welcome here. If these videos bring you something, a quieter mind, a softer night, a sense of wonder that makes the dark feel less empty and more full, then please consider leaving a like before you close your eyes. It takes only a moment, and it helps this small channel find its way to others who might need exactly this kind of stillness. And if you would like to return to new nebulae, new stars, new slow voyages through the deep, then a gentle subscription will make sure the next journey finds you when it arrives. This channel is still young, still growing, still finding the listeners it was made for. Your support, however quiet, makes that growth possible. It is, in its own small way, a little like the nebula itself. Patient, unhurried, becoming something one soft beginning at a time. Now settle in. Let your breathing slow. There is nowhere else to be, nothing waiting that cannot wait a little longer. The stars have been there for billions of years, and they will be there still when morning comes. Tonight, we drift into the Orion Nebula, and the journey begins. On a dark, moonless night, when the world has grown still and the sky opens wide above you, there hangs a small, softly glowing patch in the sword of Orion, just below the three familiar Bell stars that stretch across the winter sky like a quiet signature written in light. You may have seen it without quite knowing what it was, a point that refuses to sharpen into a star, a gentle blur amid all those crisper, cleaner points of light. It drifts there, suspended like a lantern hung carefully in the dark, asking nothing of you except a lingering gaze. And if you linger, its haze becomes apparent, a soft, diffuse presence that doesn't quite belong among the sharper stars around it, and yet belongs there more than anything. Somewhere within that tiny, luminous smudge, new suns are coming to life. The knowing of that, the quiet understanding that what looks like a faint imperfection in the sky is actually a vast nursery of stars being born, adds a deep, almost wordless sense of depth to the view, as though the sky has offered you, in that one small patch of haze, a window into something infinitely patient and endlessly generous. What makes this particular glow so tender, so accessible, is that it does not require perfect skies. Even from places touched by city lights, the nebula persists. It holds its place as the middle point in Orion's sword, that short, downward-hanging line of stars, glowing with a quiet magnitude of about 4, bright enough to find without any instrument at all. While other distant nebulae dissolve into the brightness of urban nights, this one remains, steady and diffuse, a soft reminder that the wider universe has not gone anywhere. It is simply waiting, just above the everyday brightness, for anyone willing to look. You find it easily by following what the sky has already given you. Orion's three belt stars are among the most recognized shapes in any seasonal sky, visible in winter evenings across the northern hemisphere and on summer nights in the southern. Once you've traced that familiar line, the sword falls naturally below it, and there, in the middle of that short descending row, the nebula marks itself not with sharpness, but with that gentle, unresolvable softness. The star hop from belt to sword to that glowing haze is almost like a ritual, a small, repeated journey from the known to the quietly mysterious, from the sharp to the yielding, from the bright and certain to the soft and full of becoming. When the constellation stands highest in the sky, in the deep hours of a northern winter night, when the air has gone crisp and completely still, the nebula settles into its clearest expression. Above the haze that thickens near the horizon, its faint details resolve just a little more, and its glow feels steadier, more present. At those moments under cold, dark skies, it can feel almost personal, like a quiet beacon placed directly overhead for no one else but you. Before telescopes, before photographs, before anyone understood what a stellar nursery was, human eyes looked up at this same haze and wondered. Across cultures and across centuries, that small, uncertain softness beneath Orion's belt has drawn observers into a particular kind of stillness, the kind that comes when something familiar suddenly opens into something vast. Long before anyone knew that within it, hydrogen and oxygen and sulfur were quietly arranging themselves into new stars. The glow was already there, already patient, already beautiful. That continuity is its own kind of wonder. The same gentle light that touched the eyes of sky watchers long ago now drifts quietly into yours. A calm meeting point across all of human time. When you raise a simple pair of binoculars to that hazy point, the nebula opens. What was a single soften up becomes a small, cloud-like shape, a wing of light, brighter at the center, tapering gently at the edges. There is structure now, a sense of inner brightness, and an outer spread that suggests curves, arcs, the beginning of form. It is like a window slightly wider, turning a distant speck into a softly lit, floating cloud. The darkness around it seems a little more spacious, a little more inhabited. Through a modest backyard telescope, the transformation deepens. The central region blooms into tendrils and filaments, delicate as frozen smoke, intricate as anything you have ever seen. Curved, luminous arcs wrap around a bright hollow at the heart of the cloud, and within that hollow, a small grouping of stars becomes visible. For young suns press close together, nestled in a pocket of cleared-away light. These do not appear all at once. They reveal themselves as you relax your gaze, as your eye grows quieter and gathers more light. Calm complexity slowly woven into the nebula's heart. Under the right conditions, at the brightest part of that glowing core, some observers notice a faint color, a subtle hint of green or blue, gentle as the tint of shallow water above pale sand. It hovers just at the edge of perception, cool and soft, more atmosphere than hue. Not vivid, not demanding, just a quiet wash that makes the nebula's center feel like light filtered through some still, transparent sea. An underwater quality, serene and hushed. Photographs tell the rest of what the eye cannot quite hold. Through long exposures, the nebula unfurls as a broad, winged shape, spanning roughly the width of 2 full moons placed side by side, its inner regions glowing in layered oranges and greens and reds, the light of hydrogen and oxygen and sulfur made visible. At the edges, those warmer tones fade into cooler blues and softer grays, wisps dissolving back into the dark. The visual impression is of something quietly spreading its wings in the darkness, something patient and immense, far more expansive than any single glance could contain. And yet, for all that scale, the nebula never feels distant in a cold or indifferent way. It is, in cosmic terms, remarkably near, only about 1,500 light-years from where you rest right now. Close enough that its soft glow reaches us as more than a dim smudge. Close enough that it has become a kind of window into the universe's most intimate processes. Within its luminous folds, hydrogen and oxygen and sulfur are slowly, wordlessly transforming starlight into muted shades of color, like a watercolor painted in patient strokes across millions of years. What you are looking at is not a finished thing. It is a story still in the telling. The nebula itself stretches roughly 24 light-years across, an enormous cradle of gas and dust where material flows and gathers, slowly coaxed by gravity into denser pockets, like soft clouds quietly thickening before dawn. There is no rush here. The material has all the time it needs. Those thickening pockets will gradually warm and brighten, and in warming they will transform into stars that will one day light up their own surroundings. For now, they rest in shadowed folds, patient as seeds buried in deep, quiet ground. When the Hubble Space Telescope turned its gaze toward this cloud, it assembled a mosaic from more than 500 separate exposures, weaving them into a single vast portrait of more than 1 billion pixels. Each pixel carries news from some delicate wisp of gas, some hidden knot of dust, some tiny arc of light tracing the edge of a young star's forming disk. Filaments and veils appear like fine brushstrokes on dark canvas. Fine threads and beads of gas mark the places where gravity is quietly gathering matter into future suns. Some of these threads curl in graceful arcs, others fold into compact, cocoon-like shapes, each one a quiet prelude to a sun not yet born. That same image reveals something else, something almost astonishing in its quiet abundance. Some 150 small, flat disks of gas and dust surrounding newborn stars. Protoplanetary disks, already swirling, already beginning the long, unhurried work of assembling planets. In this one region of sky, there are dozens upon dozens of private nurseries, tiny whirlpools of dust and light, each one patiently turning toward the architecture of future worlds. Moons, perhaps, oceans, skies. The thought of it expands gently outward like a slow, deep breath. Orion is not merely a place of stars. It is a garden of possible worlds, blooming softly in the dark. Held within all of this are some of the most mysterious and tender structures the universe produces. Small, dense globules nestled in the gas like rounded stones in a shallow, glowing stream. They hold their shape quietly against the flow. Some are barely visible in ordinary light, revealing themselves only in the infrared warmth they radiate, soft as a banked ember. And surrounding them all, the 4 central stars of the trapezium cluster, brilliant, luminous, impossibly young, carving out a clearer space in the cloud's heart, like a small opening in a misty forest. Their combined light fills the nebula's inner cavity with a warm, steady radiance. To imagine drifting near them is to imagine floating in a starlit fog where the light feels both delicate and endlessly patient. And all of it, the wings, the filaments, the hushed globules, the glowing disks, the 4 bright young suns, has been observed and wondered at and studied, yet somehow never fully known. Whether glimpsed as a tiny, fuzzy speck by the naked eye, or revealed in full by long exposure photography, the Orion Nebula remains, in its essence, deeply soothing to simply rest your gaze upon. Its bright core, its softly spreading wings, its surrounding field of quiet stars. These create a natural place for attention to settle and slow. A timeless, calming presence in Earth's seasonal sky, unchanged in its invitation across all the years human eyes have lifted toward it. You are here now, drifting closer, the lantern light growing gently brighter, the haze softening all the edges of the world behind you, as the soft lantern light draws you slowly deeper into the quiet heart of creation. Even as you settle deeper into stillness, the Orion Nebula you have been drifting toward is not a solitary thing. It belongs to something larger, something that breathes across enormous distances, that connects one glowing feature to the next in a vast, unhurried network. What you see as a single nebula is in truth one luminous chamber within the Orion molecular cloud complex, a sweeping region of interconnected gas and dust where star formation quietly continues across hundreds of light years. Within this complex, familiar shapes share the same broad river of material. The Horsehead Nebula with its gentle, dark silhouette, the Flame Nebula with its warm interior glow. Each one is a different eddy in a calm but persistent cosmic flow, shaped by the same slow currents that give rise to the nebula you are now floating through. To think of it this way is to feel the galaxy itself breathing, slowly in and out over millions of years, as clouds shift and compress and release, as material gathers and disperses, as one region of becoming fades and another brightens. The Orion Nebula is one serene chamber in a much larger house of creation, all of it softly lit by the light of young stars. You are not visiting a single room. You are drifting through a palace of beginnings. The light that fills this place has a particular quality, shaped by the chemistry of the gas itself. Much of it comes from ionized hydrogen, the most abundant element in the universe, which glows with a soft, warm hue when energized by the young stars nearby. But hydrogen is not alone in this conversation. Oxygen adds delicate greens, and sulfur contributes deeper reds, so that the nebula's broad clouds become layered in subtle color, like translucent fabrics draped one over another across the dark. These colors are often too quiet for the unaided eye. It is only through telescopes, which patiently gather light over long exposures, that this muted palette becomes visible, and when it does, it turns what might seem like empty space into something resembling a serene pastel landscape, a place where even the most apparently vacant corners glow with calm, hidden structure. The nebula holds within it more than one kind of light. It is classified as both an emission nebula and a reflection nebula, which means it is doing two gentle things at once. In some regions, gas is quietly energized by the stars embedded within it, and that gas produces its own faint radiance, a warm, self-sustaining glow. In other regions, the light does not come from the gas itself, but is simply starlight scattering off tiny dust grains, creating a cooler, bluish shimmer, more like mist caught in the glow of soft moonlight than anything that burns from within. Together, these two processes build a layered, luminous cloud, a place where some areas seem to radiate warmth and others shimmer as though reflecting something just out of sight. Drifting through it, you would be surrounded by light that curves and scatters around you, filling the space with a constant, gentle radiance, as if the air itself were made of quiet luminescence. This kind of object, where young, hot stars ionize the hydrogen gas around them and set it softly glowing, is what astronomers call an H2 region. The name is simple, but what it describes is anything but ordinary. It is a continuous, gentle conversation between starlight and gas, with photons slowly shaping and illuminating the cloud that surrounds them. Over long spans of time, this quiet interaction carves smooth cavities and arches into the nebula, like softly eroded stone in an ancient canyon. To float through such a region would feel like gliding through a tranquil, luminous cavern carved entirely from light and mist, a space defined not by walls of solid matter, but by the patient influence of radiance itself. The Hubble Space Telescope revealed the full depth of this conversation in extraordinary detail. Its mosaic of the Orion Nebula, assembled from more than 500 separate exposures, holds over 1 billion pixels, each one a tiny shard of light carrying news from some delicate wisp of gas or newborn star. In that vast portrait, filaments and arcs and veils of gas appear like fine brushstrokes on a dark canvas, revealing a nebula that is both grand in scale and exquisitely intricate. To let your mind wander across that image is to walk slowly through a quiet gallery of cosmic art, where every detail invites a longer, more peaceful gaze. There is no single focal point that exhausts the view. Every time your attention drifts to another corner, it finds another soft arc, another tendril, another gently lit edge hovering in the dark. At the heart of all this glowing complexity sits the trapezium cluster, a tiny grouping of young, luminous stars whose light softly fills the surrounding cloud. These 4 central stars are among the most energetic in the region, and their combined radiance gently carves a clearer space in the nebula, like a small clearing inside a misty forest. Through that opening, we are able to peer deeper into the stellar nursery than would otherwise be possible. The glow from these stars illuminates nearby gas and dust, turning invisible material into a softly shining veil. To imagine yourself drifting near the trapezium is to imagine floating in a warm, starlit fog, where the light feels both delicate and endlessly patient, where every direction offers a gentle brightness, and nowhere does the dark press too close. The cavity that the trapezium's light has carved into the surrounding cloud acts like a natural observatory window. Through this opening, astronomers can look directly into the heart of the star-forming region, something not possible in many more obscure nurseries, where dense clouds block the view from every angle. Here, the gently curved walls of the cavity glow with reflected and emitted light, outlining the hollow space like the interior of a luminous shell. To float in that open chamber is to be surrounded on all sides by calm, radiant clouds, while young stars quietly burn at the center. The darkness beyond the cavity's walls is not empty. It is full of material, full of potential, full of things still becoming. Just beyond the main nebula, the neighboring cloud M43 glows softly in its own right, connected to the Orion Nebula in a quiet union. Together, these adjacent clouds form a broader, gently luminous region where multiple pockets of star formation share the same wider environment. They are like rooms in a single, sprawling nursery, each with its own clusters of young stars and delicate structures, each with its own particular textures of gas and dust. From a distance, their combined light blends into a single, serene glow. Closer views reveal intricate variations in color and density, subtle shifts from one glowing room to the next. Drifting across this combined region, you move slowly from one quiet chamber of creation to another, never leaving the embrace of the larger cloud. Infrared light reveals yet another layer hidden within this place. When astronomers observe the Orion Nebula in wavelengths longer than visible light, they see through the cooler, denser clouds that block ordinary vision. And there, behind the veils, are more newborn stars. Previously invisible, wrapped in dust, they show themselves in the infrared as quiet points of warmth, each one a sun just beginning to take shape. To the infrared eye, the nebula becomes less like an opaque fog and more like a translucent curtain, gently parted. A dense constellation of emerging suns glows softly behind what, invisible light, appear to be nothing but shadow. Every soft cloud, this suggests, may contain stars growing in peaceful obscurity, patient, hidden, waiting for the dust around them to clear. Within the nebula's glowing folds, delicate filaments and knots of gas trace the places where material is just dense enough to begin collapsing into new stars. These structures look like fine threads and beads suspended in space, marking the quietest, most preparatory moments of stellar birth. Some filaments stretch in graceful arcs across the cloud's face. Others curl into more compact, cocoon-like shapes, each one a prelude to something larger, each one a place where gravity is doing its patient work. Think of these threads as the nebula's own gentle handwriting, the story of many future stars already outlined in softly glowing script, waiting to be read across millions of years. Embedded within the gas, there are also dense, knotted clumps, small, rounded pockets known as globules, that can shelter forming stars from the more turbulent energies of the wider nebula. These globules resemble softly rounded stones in a shallow, glowing stream, each one resisting the surrounding flow just enough to provide a calm eddy. Over time, some of these compact regions will gently collapse further, warming from within as the hidden star growing at their center grows more luminous. In the quiet of the nebula, these subtle condensations are like slow, deep breaths, small, rhythmic marks of creation's patient pace. And so the nebula holds within itself an entire spectrum of becoming. The trapezium stars carve their glowing window. The filaments trace their delicate paths. The globules shelter their quiet beginnings. The infrared glow reveals what visible light cannot reach. And in Hubble's mosaic, all of it comes together into a single, impossibly detailed portrait of a place where the universe is doing what it has always done, slowly, gently, patiently making new suns out of gas and dust and time. You drift through it now, weightless and unhurried. The warm light of ionized hydrogen wrapping softly around you. The faint colors of oxygen and sulfur layering the air like the palest of veils. The glow of the trapezium steady at the heart of the cloud. Its 4 young suns burning with a light that has been traveling through this nebula for only a few thousand years. As the soft lantern light draws you slowly deeper into the quiet heart of creation. As you drift still deeper into the nebula's glowing heart, something begins to appear in the softly lit haze around you. Shapes too small to be stars, too purposeful to be mere wisps of gas. They are disks, flat, gently turning disks of dust and gas, each one circling a newborn star like a quiet halo of possibility. In the language of astronomy, they carry a tender name: protoplanetary disks or droplets, a word that holds within it the entire future of a solar system, compressed into a small, glowing ring of material. These are the quiet seeds of worlds yet to be born, drifting through the nebula's light like something between a thought and a beginning. Some appear as softly glowing droplets, their edges catching the light of the trapezium stars and radiating it back in gentle curves. Others show themselves as dark ovals edged with brightness, silhouettes against the nebula's radiance, their interiors too dense for light to pass through. Each form is its own private nursery inside the larger nursery of the nebula itself, and there are many of them. Hubble's patient eyes found around 150 of these disks in the Orion Nebula alone, spread across its glowing face like quiet promises, each one a miniature laboratory where the slow work of planetary assembly has already begun. That number, 150, carries a particular kind of wonder. It means that planet formation is not a rare event here, not an exception or an accident. It is a common and natural outcome of star birth, unfolding in dozens upon dozens of places simultaneously, all within this one soft region of sky. Each disk is like a gentle whirlpool, calmly turning starlight and dust into the architecture of future homes. For moons, for oceans, for atmospheres, for skies that no eye has yet looked up into. To let that settle is to sense Orion not merely as a place of stars, but as a peaceful garden of possible worlds, blooming quietly in the dark. In Hubble's high-resolution images, many of these droplets reveal their shapes with remarkable clarity. Some were the form of small tadpoles, bright, rounded heads with elongated tails that trail away from the most luminous stars. These shapes arise as the outer material of the disk slowly flows away under the influence of nearby starlight, like smoke drawn gently in one direction by distant warmth. The outer layers peel back in smooth, comet-like forms, while the inner disk remains calm and protected, sheltering the beginnings of future planets within its rounded core. Seen together across the nebula's face, these tiny shapes drift like softly glowing seeds, each one holding the quiet promise of a complete planetary family. Other disks appear not as tadpoles, but as something even more still, dark, crisp silhouettes, small and perfectly cut, like ovals of shadow set against the nebula's luminous background. These silhouettes mark places where the dust is dense enough to block the light behind it, where the disk's material is so concentrated that it forms a kind of shelter, quietly protecting the fragile inner regions where planets may one day take shape. The contrast is striking, a small patch of deep shadow floating within a sea of soft radiance. And yet within that shadow, something tender is being kept safe. Allowing your thoughts to rest on these tiny shapes, you can sense how even the darkness in the nebula is gentle. Not absence, but shelter. Each of these disks is a world unto itself, and no two are quite the same. They vary in size and shape, from compact circles to elongated ovals, from tightly wound rings close to their central stars to broader, more diffuse halos of material extending farther out. Some appear wide and soft, like a breath held lightly. Others are more concentrated, wrapped closely around their young suns. This diversity reflects each disk's individual history, the particular conditions of its formation, the distance from bright neighbors, the subtle variations in the cloud from which it grew. No two planetary systems emerging from these disks will be exactly alike, even though they all share the same fundamental physics, the same quiet processes of gathering and turning and slowly becoming. Some of these disks feel the distant influence of the trapezium, stars, more keenly than others. Those that sit closer to the nebula's brightest sources of light find their outer edges gently trimmed by ultraviolet radiation. The disk's reach shortened, its outermost material slowly encouraged to drift away. This sculpting leaves them more compact, more concentrated around their central star, and yet their inner regions can remain calm and protected, preserving enough material for planets to form regardless. The result is a serene variety across the nebula. Some systems may grow wide, their planets ranging far from their star. Others will be more intimate, their worlds nestled close. All of it shaped by subtle differences in environment, all of it unfolding in its own patient way. Within many of these young disks, the process of planet formation is already underway, even at this early stage. Wide, gently turning halos of gas and dust surround the newborn stars, the first soft outlines of future planetary systems, barely distinguishable yet from the cloud that made them. Over time, tiny grains within these disks will meet and cling together, like fine mist slowly settling into something more solid. As the material continues to orbit, small clumps will grow, tracing quiet rings and bands within the disk. The architecture of future planets emerges not in sudden leaps, but in a slow, graceful choreography of countless small collisions and gentle embraces. Matter finding matter in the dark, over and over, across millions of years. Infrared observations of these disks reveal faint signatures in the light, subtle patterns that act like soft fingerprints, telling astronomers about the warm dust and gas present close to the central star, where inner planets may already be gathering. These spectral traces are too quiet to shout. They simply whisper of minerals and molecules in regions too small and too bright to image directly. Yet even those whispers carry meaning. Listening to their patterns, scientists can imagine quiet rings of emerging worlds, hidden within the glow. Rocky forms slowly accreting from silicates and metals in the warmth closest to the star, while farther out, where the light is softer and cooler, ices remain stable and lend their substance to larger, more diffuse bodies. As disks evolve, They pass through stages that leave their own quiet marks. Collisions between growing bodies can send fine dust briefly inward, replenishing the inner disk with fresh, tiny particles that glow softly in infrared light. This new haze gradually thins as the system matures, like a gentle stirring in an otherwise tranquil space, a reminder that growth continues even as the overall disk grows clearer. Slowly, the smaller dust grains are pushed outward by starlight or drawn inward by gas, and the disk's texture changes. The remaining larger particles make it more transparent, allowing the star's light to pass through more easily. From far away, this transition might look like the nebula brightening at its heart, its central star becoming more visible. Within the disk, it marks the quiet shift from thick and newborn to more open, more structured. In time, the interaction between forming planets and the surrounding disk can carve smooth gaps and rings into the material. Not abruptly, but as the cumulative result of countless tiny gravitational tugs, each orbit shaping the disk a little more. In systems like those forming in Orion, such sculpting hints at the quiet presence of hidden planets, even when the planets themselves cannot yet be seen. The disk becomes a serene, patterned record of invisible worlds, written in concentric bands of light and shadow, a map of what is coming, rendered in dust. And all of this is moving toward something. The evolution of each protoplanetary disk in the Orion Nebula is a story of gradual refinement. Diffuse clouds becoming rings, rings becoming worlds, worlds settling into lasting, stable harmony. There are no sharp boundaries in this tale, no sudden arrivals, only slowly shifting patterns of light and dust and gas, each one resolving, over immense spans of time, into something more ordered, more enduring. From our vantage point, we see only a moment in each system's transformation. Yet even that snapshot is enough to sense the universe's patient, unhurried care in shaping each quiet planetary home. Across the nebula, different disks sit at different stages of this long journey, from thick, dusty halos around the very youngest stars to more transparent systems around those that formed a little earlier. Seen together, they form a gentle timeline laid out across the sky, showing many possible steps between cloud and complete planetary system. Each disk whispers a different chapter of the same quiet story. Drifting through this region in your imagination, you move not just through space, but through the soft progression of cosmic time. From the earliest, most uncertain beginnings to the first hints of something recognizable, something that might one day hold an ocean, a moon, a morning. You float among them now, these small and luminous halos, each one a universe in waiting. The soft glow of the nebula filtering through their edges, the dark cores of silhouetted disks resting quietly against the light. 150 promises of worlds, drifting in the warm and patient dark, as the soft lantern light draws you slowly deeper into the quiet heart of creation. Within each of those softly turning disks, there's an entire world of ingredients, a quiet inventory of everything a solar system will ever need. The gas is mostly hydrogen and helium, light and abundant, filling the disk the way water fills a shallow bowl. But threaded through that gas are heavier elements: carbon, oxygen, silicon, iron. These are the materials of rocks and oceans and atmospheres, the raw substance of future worlds drifting in slow, patient orbits around stars that are still finding their footing. They swirl and mix and separate as they circle, like a calm, slowly stirred cosmic mixture. Each orbit a gentle blending, each pass around the star a soft sorting of what will become what. In the cooler, outer regions of these disks, where the young star's warmth barely reaches, simple molecules freeze onto the surfaces of dust grains, forming delicate, icy coatings. Water, carbon dioxide, simple organic compounds, they settle quietly onto the grains like frost forming on a still winter morning. Those icy mantles carry within them the potential for gentle rains and calm seas on planets that do not yet exist. They are the earliest form of what will one day be an ocean, preserved in the cold and dark at the edge of a disk, waiting with absolute patience for the long process of assembly to carry them inward. Closer to the newborn star, the temperature rises, and only the most resilient materials can remain solid. Metals and silicates, the building blocks of rocky worlds, persist in this warmer inner zone, where dust gently melts and reforms, smoothing into droplets and rounded grains that can grow into the seeds of terrestrial planets. Everything is gradual here. Everything is measured. The zone closest to the star is dry and warm and mineral-rich. The zone farther out is cool and icy and light. This quiet gradient, this slow change from hot inner regions to cold outer ones, lays out a natural blueprint, guiding where different kinds of worlds will one day find their place. Over millions of years, the dust in a protoplanetary disk gently settles toward the midplane, the thin, equatorial layer at the disk center, forming a denser concentration, like a quiet river of fine sand slowly thickening at the bottom of a clear stream. In this calmer, more sheltered zone, particles encounter one another more often, and they do so at lower speeds, making it easier for them to cling together rather than bounce apart. Slowly, almost imperceptibly, grains grow from dust to pebbles, from pebbles to stones, and eventually to larger bodies called planetesimals. Each step unfolds with patient repetition, turning a diffuse and hazy disk into something more structured, more substantial, a quietly ordered system of emerging building blocks. As planetesimals grow, their gentle gravitational pull begins to draw in more material from the surrounding disk. They swell, accumulating dust and pebbles and smaller fragments in a quiet, steady sweep through their orbits. In time, these growing bodies become full-fledged planetary embryos. Not yet planets, but no longer merely rocks. They orbit in serene paths, clearing their surroundings with a soft persistence, and the disk around them begins to show the marks of their presence. Subtle gaps, faint rings, gentle depletions in regions where a young world has passed. Not chaos, but gradual organization. The once smooth disk slowly taking on the soft pattern of something becoming. The light of the young central star plays its own quiet role in all of this. It does not illuminate the disk evenly. It warms some regions more than others, leaving pockets of shadow and differing temperatures across the disk's face. This uneven heating helps different minerals and ices condense at different distances from the star, creating quiet zones of composition within the disk, each one suited to a different kind of world. Near the star, the conditions favor the calm, slow formation of rocky planets, dense, solid, mineral-rich. Farther out, where the light softens and the temperatures drop, lighter gases and ices build more diffuse, majestic giants. The star is not forcing this arrangement. It is simply providing the gentle gradient along which matter naturally sorts itself. The dust grains themselves are not uniform. Within these Orion disks, they are a mixture of silicates, carbon-rich particles, and grains with icy mantles that carry simple organic molecules. As these grains collide and merge, their chemistry combines as well. Different materials blending into new composites, new mixtures of mineral and ice and carbon. Over time, these composites become the seeds of varied planetary surfaces and atmospheres. In a quiet, almost invisible way, the chemistry of a shadowed disk prefigures the colors of future skies and the textures of future ground. Every grain collision is a small decision, written in dust, about what kind of world something might one day be. In some disks, the gas lingers longer than the dust, forming a smooth, nearly invisible envelope around the forming planets. This remaining gas can gently shape the planet's final orbits, encouraging them to migrate slowly, gracefully, inward or outward, drifting to new positions that will define their futures. As they move, planets may settle into resonant patterns, where their orbital periods fit together in simple, harmonious ratios. One planet completes 2 orbits for every one of another. A third moves in a rhythm that locks gently with both. These arrangements turn the system into a kind of celestial music, each world circling in quiet harmony with its neighbors, the whole thing turning like a slow, peaceful clockwork. Even as planets form and migrate, the star's radiation and winds are at work on the surrounding gas. Not dramatically, but persistently. Photons and particles flow outward from the young sun, gently thinning the gas over millions of years, like mist rising off a quiet lake as morning deepens into day. The process is unhurried. The gas drifts away in gradual waves, and, as it does, the remaining solid bodies, the planetesimals, the embryos, the emerging planets, become more distinct, more clearly defined against a background that is slowly clearing. What was once an opaque, hazy disk becomes a more open space, where planets move through gentle, starlit orbits, no longer obscured by the material that made them. The timescale for this entire transformation, from dusty disk to fully formed planetary system, is long and unhurried, spanning a few million years for many Orion-like disks. In human terms, that is beyond imagining. But on cosmic scales, it is a smooth, steady transition, a single quiet chapter in a star's much longer life. During this time, disks gradually lose their gas and dust, while hidden planets grow and settle into stable paths. There is something deeply calming in this time scale. The universe is never rushed. It lets each system unfold in its own rhythm, at its own pace, shaped by its own particular arrangement of ingredients. Eventually, only a faint and tenuous ring of leftover debris remains, icy and rocky fragments that never gathered into full planets, orbiting in a loose, quiet belt around the star. These fragments occasionally meet and crumble softly against one another, releasing small clouds of dust that briefly enhance the ring's faint glow before settling back into stillness. Such a debris disk is like a gentle echo of the system's earlier, busier youth, a soft remnant of the long-finished process of planetary birth. Around stars in and beyond Orion, these quiet belts of remnants circle for eons, patient and unhurried, a calm reminder that something extraordinary once happened here. And there is one more dimension to all of this, something that makes these Orion disks feel not merely distant and scientific, but intimate and familiar. The gentle evolution of protoplanetary disks in this nebula offers a window into our own past. Our solar system likely began in a similar, softly lit environment. Our sun once wrapped in a disk not unlike those now seen as small silhouettes and glowing halos in the nebula's face. The same process is unfolding in Orion today. The settling of dust, the growth of planetesimals, the slow clearing of gas, are the same processes that, over vast stretches of time, quietly transformed an ancient disk into the familiar planets and moons we know. Thinking of this, Orion feels less distant, less abstract. It feels like a serene mirror, showing the calm, patient beginnings of our own celestial home. The protoplanetary disks of the Orion Nebula behave much like the disk that once circled our young sun, slowly transforming from a smooth, hazy ring into a structured system of forming worlds. The dust settles, clumps, and grows, echoing the quiet processes that assembled Earth and its neighboring planets. By studying their shapes and compositions, scientists gain insight into how our own planetary architecture may have emerged from a similar, soft swirl of material. In Orion's gentle disks, we see rehearsals of the same cosmic choreography that likely shaped our home. The same choreography that shaped the ground beneath your feet, the air around you, the quiet evening sky through which you are now drifting. You settle deeper into the stillness, surrounded by soft rings of turning dust, the faint warmth of a dozen young stars touching the edges of their disks. Icy grains in the cold outer reaches carrying the first quiet promise of water, of weather, of something like a world, as the soft lantern light draws you slowly deeper into the quiet heart of creation. There is a particular quality to the light in this part of the nebula, something that feels, against all reason, familiar. As you drift through the softly glowing gas and past the gently turning disks, you may find yourself sensing not just distance, but time. Because what you're looking at in the Orion Nebula is not only the birth of other suns and other worlds. It is in some quiet and profound way a reflection of your own beginning. When astronomers turn their instruments toward this cloud, they often describe it as a living illustration of how our own sun once began its life. Wrapped in a calm cloud of gas and dust, surrounded by filaments and disks that mirror the conditions thought to exist in the early solar cradle. Orion is a mirror, and in its soft glow, the story of our own star flickers gently back at us. In the nebula's heart, young stars are surrounded by exactly the kinds of structures that models predict for the early solar system. Dusty disks, thin envelopes of leftover material, wispy filaments curling through the surrounding gas. Watching those systems evolve, even from a distance of 1,500 light-years, is like watching old family photographs develop in slow motion, each image clarifying a little more with each passing observation. The sun's first light, scientists believe, rose inside a similarly protective haze. A similar warmth, a similar turning disk, a similar patient gathering of material. Orion invites us to imagine that earliest moment, the young sun, still wrapped in its birth cloud, beginning to shine. Among the most evocative objects in the nebula are those disks around stars similar in mass to our own Sunday. These sun-like stars are present throughout the Orion cluster, shining with steady, modest light, still accompanied by dusty disks or thin envelopes of leftover material from their formation. By studying their temperatures, their luminosities, the subtle signatures in their light, astronomers can reconstruct what the young sun's environment must have looked like. The gentle glow that would have bathed the early Earth, the warmth that would have touched the first grains of dust slowly assembling into our world. In these Orion stars, the sun's own earliest chapters become not just imaginable, but measurable, real, grounded in something we can observe. The chemistry within these disks deepens the connection still further. Protoplanetary disks in the Orion Nebula are rich in dust and ices. Water ice, simple organic molecules frozen onto grain surfaces, the same kinds of compounds that likely coated the building blocks of comets in the early solar system. Seeing this chemistry play out in Orion helps scientists envision how gentle deliveries of ice and organics may have once reached the young Earth, carried inward by comets and icy bodies from the outer disk, quietly seeding the surface with the raw ingredients for oceans and, eventually, for life. The water in every ocean, the carbon in every living thing, may trace a lineage back to a disk very much like those now drifting quietly in Orion's glow. Some of the most intriguing systems in the nebula are those where subtle gaps and bright rings have already begun to appear in the disk, patterns that hint at emerging planets quietly settling into their orbits, defining their futures even before they have fully formed. These structures offer close analogies to what our own neighborhood might have looked like when Earth and its siblings were still assembling from dust and rock. The same quiet gravitational tugging, the same slow clearing of material, the same gradual sculpting of a disk into something recognizable as a planetary system. Observing them, we gain a serene, external perspective on our own planet's long-forgotten construction, as if standing outside a house still being built, watching the walls rise. The broader context matters too. The Orion molecular cloud complex, that vast, interconnected region of gas and dust of which the nebula is only one luminous part, is similar in kind to the giant molecular cloud where the Sun is believed to have formed. In such regions, pockets of gas and dust gently collapse, forming not isolated stars but clusters, gatherings of young suns that share a common birthplace, that spend their earliest years in the same glowing cloud, shaped by the same environment. Our Sun likely began life in just such a gathering, surrounded by many stellar siblings before the slow drift of time and orbital motion carried them apart into the wider galaxy. By watching Orion's calm, clustered youth, we can imagine the Sun's own early days, not alone, but among a quiet, crowded family of kindred lights. Infrared views of the nebula reveal deeply embedded protostars, stars so young and so shrouded in dust that their light cannot escape at visible wavelengths. These objects glow warmly in longer wavelengths, like embers beneath a layer of ash, their presence betrayed only by the gentle infrared warmth they radiate into the surrounding cloud. The Sun, in its earliest phase, would have been exactly this: a warm, hidden presence, shining not in ordinary light, but in the softer infrared, its brightness and winds still changing and strengthening as it settled into its long, stable life. Observations of these Orion protostars help astronomers model how the young Sun evolved, how its early luminosity shifted, how its winds grew, how it gradually shed its birth cocoon and stepped into the clearer space of its own carved cavity. The mixture of stellar masses in Orion mirrors the kind of initial population our own stellar nursery likely contained. Massive, brilliant stars illuminate the cloud and gently disperse it with their winds and radiation. Smaller stars, the sun-like ones, the quiet and enduring ones, form alongside them, and then carry on long after the brightest lights have faded. In Orion, we can watch both kinds at once, the luminous and the modest, sharing the same birthplace. This balance helps scientists understand how the Sun survived and evolved amid more dazzling neighbors, how it received enrichment from their presence without being overwhelmed, how it found its steady, long-lived path through a crowded early neighborhood. That neighborhood likely had a sculpting influence on the young solar system in ways that are only now becoming clear. The gentle erosion of disks by nearby bright stars, the slow trimming of outer edges by ultraviolet light, the shortening of disk radii, the concentration of material closer to the central star, may well have shaped the Sun's own disk in its earliest years. Observations of tadpole-shaped proplyds and softly sculpted disk edges in Orion show how this process works in practice. Through them, we glimpse how external starlight may have softly defined the boundary of our own planetary nursery, perhaps encouraging the formation of planets in certain regions while leaving others less populated. The solar system's particular layout, rocky worlds close in, gas giants farther out, may carry the quiet fingerprints of those early stellar neighbors. The timelines themselves align in ways that feel almost like confirmation. The span inferred for disk evolution in Orion, a few million years from thick, gas-rich beginnings to thinner, debris-filled systems, matches the estimates for the early solar system's own transformation. Within that calm interval, planetesimals grew, planets formed, the gas gradually drifted away. By matching Orion's observed stages to these models, astronomers can better constrain how quickly our own system likely took shape, how long the disk persisted, when the planets settled into their orbits, when the last of the primordial gas dispersed into the wider cloud. The nebula becomes a gentle cosmic clock, its many disks at many stages marking the pace of our solar story's earliest chapters. There is even a whisper of something more intimate within the chemistry of ancient meteorites. Tiny, short-lived radioactive elements whose presence in early solar system rocks suggests they were delivered by nearby massive stars, perhaps in a region not unlike Orion. These stars, in their long luminous phases, steadily enriched their surroundings, seeding the surrounding cloud with materials forged in their interiors. Orion gives us a present-day example of how a cluster of young stars can share materials and influences across space. How a stellar neighborhood is not merely a collection of separate suns, but a quietly interconnected community, each member shaping the conditions for the others. In Orion's tranquil glow, we see how the sun's early neighborhood may have quietly supplied some of the very ingredients now found in ancient meteorites, in the rocks of Earth, in the atoms of your own body. And so Orion becomes more than a stellar nursery. It becomes a place of recognition, a calm, glowing region of sky where the abstract becomes tangible, where the history of our own sun and our own world can be seen unfolding in real time, at a distance of 1,500 light-years, in the softly lit faces of other disks, other protostars, other young suns just beginning their long journeys. By looking outward at Orion, we're really looking inward and backward across time to our own beginnings. Its gentle structures translate the sun's once hidden past into scenes we can study and feel. In drifting through Orion with a mind's eye, we drift through the soft dawn of our own solar story, through the same warm haze, the same patient turning, the same quiet assembling of something from almost nothing. You float through it now, past the warm glow of sun-like stars still wrapped in their birth veils, past the icy outer edges of disks carrying their quiet cargo of water and organic molecules, through the same soft, glowing haze that once cradled the star you know as your own sun. As the soft lantern light draws you slowly deeper into the quiet heart of creation, deeper still into the nebula, past the glowing disks and the softly lit cavities, past the filaments and the turning halos of dust, there are places where even the nebula's own gentle light cannot reach. Dense knots of gas and dust, cold and compact, pulled inward by their own quiet gravity. Places where the very youngest stars in all of Orion are hidden away, not yet born into the light. These are the cocoons of protostars, and within them, right now, in the slow and patient dark, something extraordinary is happening. A protostar begins as almost nothing, a slight thickening in the gas, a region where the cloud is just a little denser than its surroundings. But gravity is patient, and over time that slight density draws in more material, and more still, until a compact, warm core has formed deep inside the knot. At this stage, almost no light escapes to the outside. The object glows softly in infrared wavelengths, a warm ember behind a thick curtain. But to ordinary eyes, the structure still appears as a solid, dark shape, tranquil and unchanging. Only instruments sensitive to longer wavelengths can hear the quiet news from within, that something is gathering, warming, slowly preparing to shine. In Orion, the youngest of these protostars tend to lie right along the densest spine of the cloud, the narrow filament where gas and dust are most concentrated, where gravity finds the most material to work with. Here, along that hidden ridge, a quiet chain of embryonic stars stretches through the nebula, each one so deeply buried that most of its light is muffled and re-emitted at wavelengths invisible to ordinary sight. Imagining this filament is like picturing a gentle river of becoming, a narrow, hidden corridor where the next generation of suns is forming in sequence, one after another, each one slowly brightening in its own sheltered pocket of the cloud. As a protostar continues to gather material and its core temperature rises, it enters a new phase. It begins to drive gentle outflows along its poles, narrow streams of gas and particles moving outward through the surrounding cloud, carving soft corridors in the material around them. These outflows are not explosive or violent. They are more like slow, steady breaths, making quiet paths in the mist. The young object is still not yet a full star, but its growing warmth and the subtle motion of its winds are already reshaping the immediate neighborhood. It announces itself not with a sudden blaze, but with these soft, sculpting motions, the first whisper of a presence that will eventually light up its surroundings. Eventually, as the density and temperature at the core rise high enough, something fundamental changes. Hydrogen nuclei begin to fuse into helium, releasing energy in a steady, self-sustaining flow. The protostar becomes a young main sequence star, but this transition does not announce itself dramatically from the outside. What an observer would notice, watching from a distance, is simply that the object steadies, its brightness growing more consistent, its light more even, the flickering and variability of its younger phase giving way to a calmer, more reliable glow. Around it, any remaining envelope of gas thins and drifts away, and the star steps out from its cocoon into the softly glowing cavity of the nebula. In Orion, many such stars are only a few 100,000 years old, still in the very first quiet chapters of lives that may last for billions of years. The brightest of Orion's young stars may be as little as 10,000 years old. 10,000 years is barely a heartbeat on cosmic timescales, a span so brief that in the history of the universe, these stars have only just arrived. Yet their light is already strong enough to gently ionize the surrounding hydrogen, making the nebula glow, softly illuminating the gas and dust in which many other stars are still forming. They are like lanterns placed in a nursery, warm and steady, their presence quietly nurturing the environment around them even as they themselves are barely past their own beginnings. Powerful newborn suns, wrapped in an environment that remains calm and protective, holding many others still in earlier stages of becoming. Once a young star has reached the main sequence and shed much of its birth shroud, it begins a new kind of life, no longer hidden, but not yet far along its journey. Traces of its origin remain in the nearby wisps of gas, in the thin disk still circling close, in the faint infrared glow of material not yet fully dispersed. These infant suns have stabilized, but the memory of formation lingers around them like a soft haze. They contribute to the clustered sparkle that gives the nebula's heart its lively yet peaceful quality. Dozens of young stars shining freely for the first time, their light mixing and blending into the broader, radiant atmosphere of the nursery. As these infant stars age, even slightly, their motions carry them gently outward from the dense filament where they were born. The youngest protostars remain near the spine of the cloud. The slightly older stars drift beyond it, fanning out into the wider nebula like seeds carried a little way from their parent branch by a soft breeze. Over time, this creates a subtle spatial ordering of ages across the nebula's face. The youngest objects concentrated in the densest regions, the older ones spread more broadly around them. The nebula quietly arranges its children in space as they grow, tracing their life stages not just in brightness and color, but in position, laying their history out across the sky like a gentle map of time. Among Orion's young population, most stars are not the spectacular, massive variety that dominate the cluster's brightest light. Most are low-mass stars, smaller and dimmer than our sun, modest in their brilliance, but extraordinary in their endurance. These stars burn their hydrogen slowly and steadily, like long, patient embers rather than roaring flames, and their gentle light will outlast that of their more luminous neighbors by billions of years. In the crowded cluster, they form a soft, enduring backdrop behind the bright central giants. Quiet, persistent hearts that will still be shining long after the nebula itself has dispersed and the memory of the nursery has faded into the wider galaxy. Among the quietest members of Orion's young population are the brown dwarfs, objects that form from the same collapsing clouds as their stellar siblings, but never quite accumulated enough mass to sustain hydrogen fusion. They glow faintly from residual warmth and the slow heat of contraction, radiating mostly in infrared, like coals fading in the dark. They are neither full stars nor planets, but something gentle and in between, subtle presences at the quieter edges of the cluster's life, filling in the space between the smallest true stars and the largest forming worlds. In the nebula's soft light, they are like whispers at the edge of hearing, small, enduring, easy to overlook, and yet entirely real. The Orion Nebula cluster itself, taken as a whole, is a very young open cluster, still partly wrapped in the remnants of its birth cloud, still in the process of revealing itself. Over the next 100,000 years or so, much of the remaining gas and dust will be gently pushed away by the light and winds of the cluster's brightest members. The filaments and veils that now give the nebula its intricate, layered appearance will slowly thin into faint wisps. The stars will continue in their calm orbits, now against a darker, quieter backdrop. What is now a nursery glowing with the energy of recent formation will gradually become a serene, open cluster of young stars hanging freely in space, its members slowly drifting apart across long ages. At the center of all this stellar youth, the most massive stars in the trapezium are already doing the work of caretakers. Their intense light and winds carving the glowing cavity, sculpting the surrounding clouds, shaping the environment in which gentler processes unfold nearby. They burn with a fierce and steady brightness that will not last as long as their lower mass companions. But for now, they are the luminous anchors of the whole region, the central focal point around which the nursery organizes itself. They hold the light of the nebula steady while, in the softer outskirts of the cluster, the quieter, more enduring stars go about the patient business of becoming. And so Orion at this moment holds many stellar lives at once. Cocoon protostars still hidden in their dense knots, infant suns just stepping into the light, low-mass stars settling into their long, slow burns, and brown dwarfs glowing faintly at the edges of everything. It is a village at many hours simultaneously, some of its inhabitants still sleeping, some just waking, some already moving through the early hours of a very long day. All of them born from the same quiet cloud, all of them carrying forward the story of a stellar nursery that began millions of years ago and continues, gently and without hurry, right now. You drift among them in the soft dark, past warm infrared glows where protostars are still gathering their first light, past the steady, newborn shine of infant suns just emerged from their cocoons, past the quiet, faint warmth of brown dwarfs at the edges of the cluster, as the soft lantern light draws you slowly deeper into the quiet heart of creation. If you could hold the entire Orion cluster in your gaze all at once, every protostar still wrapped in its birth cloud, every infant sun just stepping into the light, every modest low-mass star settling into its long and patient burn, you would be looking at something that resembles, more than anything else, a village at dawn. Some of its inhabitants are still in the deepest sleep of their formation. Others are stirring. Others already moving quietly through the early hours of lives that will stretch for billions of years. Each kind of star contributes something different to the light of the whole, and together they shape the nebula's radiance into something layered, varied, and deeply calm. The most massive stars, the bright, hot members of the trapezium cluster at Orion's heart, dominate the scene with their ultraviolet glow, the light that ionizes the surrounding hydrogen and sets the nebula shining. Their contribution is intense and unmistakable, the primary source of the broad, warm luminosity that fills the cluster's central cavity. But behind and beneath that brightness, smaller stars and brown dwarfs add a quieter, redder background, a softer layer of light that fills in the spaces between the bright central suns, lending the region a warmer, more nuanced tone. The blend of all these contributions creates a spectrum of light that shifts slowly as the population ages, even while the nebula continues to appear serenely luminous to any eye looking up from Earth. The overall energy of the cluster is shaped by this mixture: the fierce output of a few massive stars, the steady modest glow of many sun-like ones, the faint infrared warmth of brown dwarfs at the edges. No single kind of star tells the whole story. It is the interplay between them, the layering of many different luminosities and temperatures, that gives Orion its particular quality of light, at once brilliant and gentle, at once young and varied. To float through it is to move through a space where every frequency of light is represented in some soft proportion, where the darkness between stars is never truly empty, but always faintly, warmly lit. When we observe the Orion Nebula today, we are seeing many phases of early stellar life all at once. Cocooned protostars still invisible to ordinary light. Emerging infant stars just beginning to shine freely. Low-mass dwarfs in the quiet early chapters of billion-year lives. Massive cluster leaders radiating with the full intensity of youth. It is as if we are watching a quiet village at dawn, with newborns, children, and young adults all sharing the same softly lit streets, each one at a different moment in the same broad arc of becoming. Each type of star follows its own path, moves at its own pace, burns with its own particular fire, and yet all of them are held within the same tranquil nebular glow, shaped by the same original cloud, connected by the same shared beginning. What makes this scene even richer is that it represents not a single moment of star formation, but several overlapping ones. Studies of the Orion cluster suggest that star formation there occurred in distinct waves over a span of a few million years, not all at once, but in successive pulses, each one adding a new generation of stars to the gathering. This layering means that some stars are slightly older, already shining with a certain settled confidence, while others are newly formed and still adjusting to their place on the main sequence. The cluster is not a single cohort, but a continuum of ages, a flowing story of star birth written across overlapping generations, all of them sharing the same soft, glowing cradle, all of them part of the same long, unhurried unfolding. The presence of these multiple generations gives the region a sense of ongoing life, a calm cycle of beginnings that has been running for millions of years and continues still. As older young stars move gently outward from the densest regions and new protostars quietly ignite within the remaining cloud, the nebula renews its population in overlapping waves. It is not a place that formed its stars and stopped. It is a place that has been forming them continuously, patiently, in successive quiet pulses, a nursery that keeps opening new rooms even as the earlier ones begin to empty. Floating through Orion in your imagination, you would encounter not just one stellar age, but a softly blended sequence of stellar childhoods, each one a little further along than the last. Beyond the nursery's innermost regions, in a wider constellation of Orion, some stars have already moved well past their earliest phase. They have settled into mature, main-sequence lives, their inner fusion steady and unhurried, their light calm and unwavering. These stars no longer wear the thick veils of their birth clouds. They have shed those wrappings long since, and now drift through the broader stellar field with a quiet confidence. Older siblings, in a sense, watching from a little farther away as the nursery behind them continues its work. Their light is less intense than the hottest newborn stars, but it is more enduring, more settled. In their steady glow, you can sense the middle chapters of stellar life, where change slows and quiet stability takes hold. Many of these more mature stars formed earlier than the luminous infants now lighting the nebula's heart, and have already drifted slightly away from the brightest gas. They trace gentle arcs through the constellation, carrying with them the memory of a long-faded cloud, the birth environment they have since outgrown. Their light appears calm and unwavering, neither the fierce blue-white of extreme youth nor the warmer tones of later evolutionary stages, but something in between, the steady, reliable shine of a star in the long middle of its life. Seen against the nebula's soft background glow, they're like older travelers who have walked a little farther down the road, their pace unhurried, their direction clear, while the nebula's youngest stars shine with hot, blue-white light. These more mature members contribute warmer, yellower tones to the broader stellar tapestry. Their colors are a sign of cooler surface temperatures, not of diminishment, but of a quieter, more settled energy. When you look toward the wider Orion region, you are seeing these hues blend together. The sharp blue-white of newborn suns, the steadier yellow and gold of those a little further along, all layered into a single, tranquil field of light. This mixture gives the region a feeling of depth, as though several pages of time are visible simultaneously in the same patch of sky, each one softly overlapping the next. In the life of a star, the main sequence phase, that long, stable season of hydrogen fusion, is a period of extraordinary endurance. The internal fusion rate balances precisely against the weight of the outer layers, producing a brightness and a size that can remain nearly constant for billions of years. For any planet orbiting such a star, this constancy is a gift, a reliable, gentle warmth sustaining the same environment across timescales almost too long to conceive. In Orion's broader stellar family, the mature main sequence stars form the quiet backbone of what the constellation will become. Not the brightest members, not the most dramatic, but the most lasting, the most dependable, the long-burning embers around which future planetary systems will spend their lives. Some star fields in the wider Orion region present both young blue stars and older, redder ones sharing the same general territory, each representing a different chapter of stellar life, coexisting without conflict in a quiet neighborhood. The blue stars are like new, brightly burning candles, their light sharp and clean. The redder, older ones are broader and more mellow, glowing with a deeper warmth that speaks of longer experience. Neither disturbs the other. They simply exist together in the same soft darkness, each following its own arc, each adding its own color and character to the shared scene. This peaceful coexistence of ages gives the broader Orion region a layered, contemplative character, where past and present stellar stories overlap in the same quiet sky. Taken all together, the hidden protostars, the infant suns, the modest low-mass dwarfs, the brown dwarfs at the edges, the young cluster members stepping into their first stable light, the slightly older stars drifting into the wider field. The Orion Nebula and its surroundings form a gently orchestrated pattern of stellar life in all its early phases. Each kind of object moves at its own pace. Each shines in its own way. Yet all of them share the same quiet starting place in the cool, dense clouds of the region. All of them carry the same origin forward into their different futures. For now, Orion is in its early, luminous chapter, where most of its stars are still young and the gas still glows softly around them. To rest your thoughts here is to rest them in a cosmic childhood, where everything is new and calm and slowly, gently unfolding. You drift among them in the soft radiance, past the blue-white intensity of newborn suns and the steadier golden glow of those a little further along, past the quiet arcs of stars that have already moved beyond their birth cloud, carrying their origins gently into the wider dark, as the soft lantern light draws you slowly deeper into the quiet heart of creation. As you drift further through the Orion region, the quality of the light around you begins to shift, almost imperceptibly at first, like the difference between early morning and mid-morning, between the sharp clarity of a new day and the softer, more settled warmth that follows it. The fierce blue-white glow of the youngest stars gives way, in places, to something deeper and more mellow. Reds and oranges appear among the stellar field, warmer tones that carry within them not the energy of new beginnings, but something equally beautiful and far more serene. The quiet dignity of stars in the long, unhurried middle of their lives, and in some cases the first gentle signs of something changing, deepening, blooming softly into a new phase. Some of the stars associated with Orion's broader region have already moved well beyond their youthful phase. Deep within their cores, the hydrogen that once fueled their long, stable shine has been largely consumed, and fusion has begun to continue in surrounding shells instead. The outer atmosphere responds to this shift slowly, over vast spans of time, swelling and softening, cooling at the surface even as the interior remains energetically active. The star grows larger and redder, its light mellowing from the sharp intensity of youth into something broader and more diffuse. This transformation is not abrupt. From any short vantage point in time, the star appears perfectly still, perfectly steady. The change reveals itself only across deep time, unfolding like a slow and graceful blooming that takes millions of years to complete. A red giant glows with a warmth that feels fundamentally different from the hard brightness of a young, hot star. Its surface temperature is lower, its color richer, its light more like the glow of something ancient and settled than the crisp radiance of something newly made. The star's outer layers have become more diffuse, spread across a volume far greater than the original star occupied, so that from a distance its light feels less sharp and more enveloping, like the warmth of embers rather than the brightness of a flame. There is a peacefulness to it, a sense that the star has taken a long, slow breath and expanded into a quieter, more spacious way of shining. In that soft radiance, we glimpse a stage of stellar aging that is not diminishment, but deepening, an expression of energy that has grown broader, gentler, more spread across the dark. Red giants in the Orion region do not simply hold their expanded shape steady. They pulsate, slowly, rhythmically, their outer layers expanding and contracting in gentle cycles that play out over weeks or months or years depending on the star. These pulsations cause subtle variations in brightness, a slow and regular heartbeat written in light. To observe a single moment is to see nothing unusual. The star appears as a steady, warm point, but recorded over time, its gentle oscillation reveals itself, rising and falling in a calm, repeating pattern. In Orion's evolved stars, these quiet rhythms add an internal music to the region's luminous tapestry, a soft pulse beneath the stillness, marking the steady passage of time in a language of light. For some of the more mature stars in Orion's broader association, the passage into the red giant phase marks the last long, stable chapter before later transitions carry them still further along their evolutionary path. But even knowing that, there is no need to hurry past this moment. The star in its red giant phase is not on the edge of something dramatic. It is settled into a period that will itself last for a very long time, radiating its warm, diffuse light steadily into the surrounding darkness. It is an elder in a calm season, its surface gently cooling, its light mellowing, its presence in the sky as real and as enduring as anything else in the constellation. To rest your attention on such a star is to rest it on something unhurried and wholly at peace. Not all of the lower-mass mature stars near Orion will swell into large, luminous red giants. Many will follow quieter, more understated evolutionary paths, expanding modestly, cooling gradually, changing without extremity or drama. Their transformations will be slow and subtle, more like aging gracefully than undergoing metamorphosis. Even in their later stages, these stars will remain relatively faint, unremarkable to casual observation, soft and steady points of light contributing to the gentle background of the broader stellar field. They show that not every stellar life culminates in grandeur. Some simply deepen into softer, cooler forms, shining on without fanfare for longer than most things in the universe endure. Some of the red giants near Orion have shed enough of their outer material to form faint, extended envelopes around them, tenuous shells of gas that have drifted outward and now float in the surrounding space, illuminated very softly by the light of the star at their center. These envelopes glow like the most delicate of halos, like breath visible in cold air, like the memory of something the star once held close and has since released. They represent layers of the star's own past, gently given back to the wider medium, the outermost atmosphere of a star, now floating free. To imagine such a star is to picture a warm, quiet light wrapped in its own luminous history, surrounded by the ghost of what it used to be. The material that moves outward in these slow stellar winds is not simply dispersed and lost. Red giants and the mature stars near Orion contribute heavier elements to the surrounding medium through these steady, gentle outflows. The products of long fusion cycles, carbon and nitrogen and other elements forged across billions of years in the star's interior, now drifting outward into the wider cloud. At any given moment, this process is quiet and nearly invisible, a slow diffusion of matter from star to space, too gradual to watch and too vast to fully picture. Yet over millions of years, this continuous, almost imperceptible enrichment quietly shapes the chemistry of the interstellar medium. One day, that material will join new nebulae, new collapsing clouds, new stellar nurseries. The atoms released by a red giant near Orion today may eventually find their way into a future planetary system, completing a cycle so long and so gentle that it is barely distinguishable from stillness. Some of the evolved stars associated with Orion have already moved away from the bright, active regions of the nebula and now drift through more diffuse, darker parts of the broader constellation, regions where background starlight is sparse and the sky is quieter. Here, far from the energetic turbulence of active star formation, they spend long ages in relative solitude, their light appearing particularly steady, particularly contemplative. They are like travelers who have walked beyond the village lights into a calm, open countryside, where the only sound is the faint, regular rhythm of their own slow pulsations. Their isolation does not diminish them. If anything, it makes their glow feel more considered, more deliberate, a single warm point holding its own against the depth of the dark. When astronomers plot the brightness and color of stars in Orion-related clusters together, arranging them on a diagram that maps temperature against luminosity, a graceful pattern emerges. Most stars fall along a smooth, diagonal band, the main sequence tracing the long, stable phase of hydrogen fusion. But at one end of that band, where the most massive and most evolved stars reside, the track bends away, curving upward and to the right toward the realm of the red giants. This bend, called the turn-off point, marks the place where stars have been shining long enough to begin leaving their stable youth behind. It is like reading the cluster's age in a single, elegant stroke, a curve in a diagram that encodes millions of years of stellar history. In Orion's related clusters, this curve tells us how long the region has been forming stars, and how many of its members have already begun their graceful departure from the main sequence. Seen in long exposure images, the mature stars and red giants connected with Orion soften the overall appearance of the stellar field, adding rich reds and warm oranges among the sharper blue lights of the very young. Their subtler colors blend into the broader palette of the region, reducing any sense of harshness, tempering the intensity of the younger suns with something deeper and more mellow. They give the scene a warmer, more balanced character, like autumn leaves mixed with spring blossoms in the same quiet garden. Each one beautiful, each one at a different stage, all of them part of the same long, unhurried story of stellar time. Taken together, the mature stars and red giants associated with Orion remind us that even in a region famous for newborn suns, there is also longevity and graceful aging and the quiet dignity of lives stretching far beyond the nursery. While the nebula itself blazes with the fresh energy of young stars, these older presences offer a deeper perspective, a reminder that stellar lives extend far beyond their beginning. That the glow we see in Orion is only the opening of something much longer and much more varied. Their steady, mellow light adds depth and calm to the scene, hinting at futures that extend well past the current haze, at stories already partway told, at a universe that is always, in every direction, in the middle of becoming something. You drift among them now, past the warm red glow of stars that have expanded into their elder years, past the faint, soft halos of shed material drifting in the dark around them, through the quiet, settled light of stars that have been shining since long before the youngest protostars in the nebula were even a slight thickening in the gas, as the soft lantern light draws you slowly deeper into the quiet heart of creation. There is a particular kind of stillness that belongs to a cathedral, that quality of hushed, vast space where light enters from high above and falls in soft columns through the dimness, where every surface holds a quiet depth, and where the architecture itself seems to invite a slowing of breath, a settling of thought. The interior of the Orion Nebula has something of that quality. As you drift deeper into its glowing heart, the structures that rise around you are not walls of stone, but columns of gas and dust, tall, dark, softly outlined against the luminous background, shaped over thousands of years by the same patient forces that carve canyons from rock. And like the columns of a cathedral, they do not merely divide the space. They shelter what is within them. Along the bright interior of the nebula, dust pillars rise in gradual silhouette, their forms emerging from the general glow, the way shapes emerge from mist as you draw closer. They are tall and relatively narrow, their upper reaches pointing into the nebula's most luminous regions, their bases anchored in the denser, cooler gas below. On their sunlit sides, the faces turn toward the cluster's brightest stars. Fine details appear, soft ridges, subtle curves, wisps of material that seem to peel gently away from the surface like thin layers of fog. On the shadowed sides, facing away from the light, the pillars fade into deeper darkness, their interiors hidden, whatever tender beginnings lie within kept cool and protected from the stronger radiation outside. Each pillar is a calm, three-dimensional presence, not flat, not simple, but a sculpted shape suspended in light, a refuge made from gas. Within those shadowed interiors, conditions remain exactly what the youngest, most fragile stages of star formation require. The surrounding nebula glows with energetic radiation, but inside the pillar, the gas and dust absorb and block that energy, keeping the core cool and quiet. Gravity can work here without interference, slowly drawing material together into the dense concentrations that will one day become protostars. The pillar is not passive, it is actively sheltering. It stands between the forming star within and the harsher environment without, offering a protected pocket of becoming inside the broader, more energetic nursery. From a distance, these pillars look like fingers of darkness reaching into a luminous sea. Up close, they're sanctuaries. Near the tips of some pillars, where the dark column tapers toward its narrowest point, small and dense globules appear. Rounded knots clinging to the ends of the structure like droplets gathered at the tip of a branch. These compact pockets have their own sheltering effect, their density providing a cool, quiet space in which the earliest stages of star formation can proceed, even as the surrounding material slowly erodes away. Their shapes are simple and softened by distance, rounded, slightly elongated, darker than the material around them. To picture them is to picture tiny nests at the ends of softly glowing branches, each one holding something still forming, still gathering, still too young and too delicate to be exposed to the open light. Against the luminous background of the nebula, dark and compact globules stand out with quiet clarity, small islands of shadow in a sea of soft radiance. They are denser than the gas around them, and that extra density gives their gravity a slight advantage over the dispersing influence of nearby starlight. Material within them can continue to draw together, slowly and without disruption, in the calm at the center of their own small gravitational well. The nebula's glow wraps around them, tracing their outlines like halos, making each one visible precisely because of the contrast between its dark interior and the brightness behind it. They are waiting places, quiet, patient, unremarkable to a passing glance, and yet each one a potential cradle. Not all of the nebula's dust structures are as massive or as tall as the great pillars. Some stretch into soft, curling filaments, slender threads of denser material that wind through the gas like fine strokes of ink drawn across luminous paper. These threads are less imposing than the pillars, more subtle, but they too mark something meaningful. The places where gas and dust are just dense enough to resist the surrounding light, just concentrated enough to hold their form against the gentle pressure of the radiation field. They guide the eye slowly across the scene, from one pocket of density to another, tracing the invisible currents that move material through the nebula. In their subtle curves, there's a record of slow motion, of the nebula's quiet internal flows, made visible in the contrast between dark thread and bright background. In other regions, broad and tranquil silhouettes spread across the nebula's face, clouds too wide to be called pillars, their edges not sharp but feathered and soft, blending gradually into the surrounding glow. These features do not block the light entirely. They soften it, filtering the nebula's brightness into something more muted and more calming, like a sheer curtain drawn across a bright window. The shadows they cast are not hard-edged, but gradual, a gentle dimming that tempers the illumination of the spaces within. Inside their dim embrace, dust and gas can continue their quiet work without being overwhelmed by the energy outside. The shadow here is not absence. It is a kind of care. At still finer scales, high-resolution images reveal small, tear-shaped patches within the nebula, compact globules whose tapered forms tell a specific story. Their rounded heads face the brightest stars, absorbing the radiation that strikes them. Their subtle tails trail back in the opposite direction, sculpted by the same radiation pressure that shapes their heads, pointing away from the light like weather vanes in a stellar wind. Inside, the densest material remains wrapped and secure, protected by the surrounding layers, even as those layers are slowly worn away. These shapes speak of a patient, continuous conversation between light and matter. Light pressing outward, matter resisting inward, the compromise between them resolving slowly into these small, precise, quietly eloquent forms. Where multiple veils of dust overlap, the effect deepens into something that suggests genuine depth, one semi-transparent cloud lying in front of another, each one dimming the light behind it just a little, the combined effect creating a layered, receding sense of space. Light that passes through these stacked shadows arrives softened by each layer, its brightness reduced in gentle steps rather than all at once. To drift through such a region would be to pass through successive curtains of dusk, each one a little dimmer than the last, the stars beyond becoming gradually more obscured and more distant. It is a reminder that even in space, darkness and light do not meet abruptly. They mix gradually, gently, each yielding a little to the other in a long and quiet negotiation. Where the outer surface of a pillar or globule faces the most energetic nearby stars, the material at the very edge becomes ionized, its outermost atoms gently excited by the incoming radiation and made to glow. This glowing rim outlines the pillar's shape like a softly lit border, a thin luminous edge between the dark interior and the bright surrounding nebula. The effect is like looking at clouds backlit by a low sun, their edges touched with brightness while their interiors remain still and gray. In the nebula, these outlined forms make each pillar and globule into something defined and individual, each one given a specific shape by the light that is slowly working to unmake it, each dark sanctuary traced in its own quiet glow. Where dust lanes cross brighter regions of gas, they appear as graceful, dark strokes dividing one luminous area from another, lines drawn not by any deliberate hand, but by the flow of material along the nebula's internal currents. These lanes may mark paths where gas is still moving slowly through the cloud, feeding denser regions, transporting material from one part of the nursery to another in a quiet, ongoing circulation. From a distance, they give the nebula a sense of order and calm structure, like the grain of wood or the veining of a leaf, a pattern that is not imposed but grown, emerging from the physics of the place itself. In their soft, dark lines, the nebula reveals something of how it organizes itself from within. Some cloud surfaces in Orion show subtly scalloped edges, profiles gently indented into rounded, wave-like curves, each one a record of the balance struck between the outward pressure of radiation and the inward pull of gravity. These indentations are not violent. They are the shape of equilibrium, of two opposing forces finding their measure of each other in slow, incremental adjustments over thousands of years. The result looks almost handcrafted, as if the nebula's surfaces have been worked by a patient and invisible sculptor, pressing here, yielding there, until the edge resolved into its particular softly notched form. They add a quality of delicate craftsmanship to the scene, a sense that even the boundaries between light and dark in this place are the product of long, careful work. Certain pillars and globules are partially hidden behind brighter curtains of gas, their presence betrayed only by slight dimmings in the background light, by subtle changes in texture, by the faintest suggestion of a darker shape behind the glow. These partially veiled structures hint at how many layers the nebula contains beyond what first meets the eye. To imagine drifting through it is to imagine passing through one glowing wall of gas and discovering an entire landscape of shadowed shapes behind it. More pillars, more globules, more dark and sheltered spaces, each one another quiet room in the same vast, softly lit cathedral. The nebula is not a single surface. It is a sequence of depths, each one opening onto another, each one holding its own soft darkness and its own quiet promise of something becoming. You move through it now in perfect stillness, past the dark spires and their softly glowing rims, past the rounded globules cradled at the tips of fading columns, through the layered curtains of shadow and light. The cathedral vast and patient around you, its columns carved from gas, its light forever shifting at the edges of the dark, as the soft lantern light draws you slowly deeper into the quiet heart of creation. Beyond the great pillars and their softly glowing rims, beyond the broad silhouettes and layered veils, the nebula holds something even quieter. Structures so small they might seem insignificant against the cathedral's vast scale, and yet are perhaps the most intimate places in the entire cloud. Tiny dark shapes, some only a fraction of a light year across, drift against the luminous background like seeds resting on still water. They are modest, unhurried, easy to overlook. And within them, in conditions of extraordinary stillness, the universe is doing some of its most tender work. The smallest of Orion's dark silhouettes are not the remnants of grandeur. They are complete in themselves, compact, self-contained pockets of dense gas and dust where conditions are just right for one star, or perhaps only a few, to form in relative solitude. Away from the busier, more crowded regions of the nursery, these modest globules offer a quieter version of the same process unfolding everywhere in the nebula. The slow gathering of material, the patient accumulation of density, the gradual warming of a core. On a smaller scale, they echo the same physics that shapes the larger structures. They are like tiny, secluded gardens tucked inside the broader landscape, each one following the same ancient choreography in its own sheltered corner of the cloud. Some of the nebula's smallest dark features are not newly formed structures at all, but survivors, isolated knots that were once part of larger clouds, slowly eroded down to their most resistant cores. The surrounding material has been worn away over thousands of years by the persistent influence of nearby starlight and stellar winds, leaving behind only the densest, most tightly bound pockets. Even diminished, even reduced to their essential form, these remnant knots can still harbor the concentrations of gas needed to give birth to a star. They are like the last sheltered coves of a once broader continent of dust, smaller than they were, but no less capable of what they were always meant to do. What makes these dark globules particularly striking in deep images of the nebula is the contrast they present, appearing almost perfectly opaque against the luminous background, as dark and definite as anything in the sky. And yet that darkness is not emptiness. Within each black silhouette, almost certainly, lies an intricate internal structure invisible to ordinary light. Fine threads of denser and less dense material, nested clumps at different stages of condensation, subtle variations in temperature and density that together create a quiet maze of paths along which gas can flow and gather. Every dark shape that looks like a simple block of shadow is, in reality, a layered and complex interior, a small world of its own, holding its intricacy behind a featureless face. The densest of these compact cores can collapse inward until a protostar begins to form at the center, a point of growing warmth hidden so completely that only infrared or radio observations can detect its presence. From the outside, the globule still appears as a solid, tranquil shape, giving nothing away. Its surface looks the same whether it is simply a dense cloud or whether it already cradles a new sun at its heart. The secret is kept entirely within. Only by looking in wavelengths of light that can penetrate dust does the interior reveal itself. A warm, concentrated point glowing faintly in the dark, like an ember forming deep in a banked fire. These secretive beginnings give each shadowed shape the quality of a protected cradle, outwardly still, inwardly alive. Some of the dust pillars in the nebula are oriented in a way that is not random, their long axes pointing roughly toward the brightest stars in the trapezium cluster, like quiet compass needles aligned with the dominant source of radiation in the region. This orientation is not coincidence. It is a record of how those pillars were shaped. The radiation and winds from the cluster's most luminous members pressed into the surrounding cloud from one direction, pushing material back and sculpting it into elongated forms that lean, persistently, toward the light that formed them. To notice this alignment is to sense the nebula's subtle directionality. The way starlight provides not just illumination, but a kind of calm guidance, organizing the gas and dust around it into shapes that reveal the invisible flow of energy through the cloud. Between the darkest silhouettes and the brightest emission regions, the nebula offers something gentler still. Transitional zones where gas and dust intermingle without clear boundary, where light is filtered rather than simply blocked or freely passed. In these soft, mottled regions, the transition from luminous to dim happens gradually, like the fading of twilight into night rather than the sharp edge of shadow on a sunlit wall. The result is a gentle gradient, a continuous blending of brightness into darkness and back again, giving the nebula in these places a tender, dreamlike quality. Nothing is decided here. Everything is in the process of becoming one thing or another, suspended in a long, calm moment of transition. The outer layers of pillars and globules do not hold their form forever. Slowly, gently, those outermost surfaces flow away under the influence of the radiation and stellar winds that press upon them. Not in a sudden dissolution, but in a gradual thinning, like a hillside shaped over centuries by wind and rain. As material erodes from the surface, new contours emerge beneath it, revealing inner structures that were previously hidden. Ridges and nested shapes become visible that were once buried inside the pillar's bulk. During this long unveiling, the sheltered interiors may still be doing their quiet work of star formation, even as the exterior changes shape around them. The process feels less like destruction than like slow revelation, a patient uncovering of what was always within. Within the darkest globules, the depth of the shadow is its own kind of wonder, almost perfectly opaque in visible light. These small shapes absorb nearly all the radiation that strikes their faces, leaving behind a darkness so complete it looks painted. And yet that opacity is the very thing that makes them sanctuaries. The same density that blocks all light from passing through also prevents the energetic radiation outside from penetrating inward. The gas within is kept cold by this shielding, cold enough for molecules to form, cold enough for the delicate chemistry of star formation to proceed, cold enough for gravity to work without competition from the thermal pressure that warm gas would exert. The darkness is not incidental to what happens here. It is the condition that makes it possible. Altogether, the dust pillars, globules, filaments, silhouettes, and shadowed lanes of the Orion Nebula transform the cloud from a simple luminous fog into a richly textured, three-dimensional sanctuary, a place of extraordinary depth and variety, where light and shadow coexist in endless, gentle negotiation. Every dark shape is a harbor. Every bright rim is a boundary between safety and exposure. Every gradual transition from luminous to dim is another soft room in the same vast, sheltering structure. The nebula becomes not a single thing seen from the outside, but a landscape moved through from within, a space of many layers, many scales, many kinds of quiet, each one offering its own particular form of shelter to whatever small beginning is taking place inside it. And within that landscape, there's a mirror of something closer to home. When we look at the dark disks edged with light, the proplyds silhouetted against the nebula's glow, we are seeing snapshots of stages our own solar system very likely passed through. Try to picture the early sun at the center of a similar silhouette, its future planets still only soft outlines in a swirling ring of dust, its disk still catching the light of surrounding stars at its edges. Orion's disks let us visualize those hidden steps with a clarity and calm that no other region of sky can offer, turning abstract models into tangible scenes, inviting us to picture Earth as once being just a quiet swirl inside a glowing, protective cradle not so different from the ones drifting before us now. Every observation of the Orion Nebula, every measurement of its chemistry, its structure, its motion, feeds into the models that attempt to reconstruct the sun's first few million years. In its soft light, those models are refined and tested, step by step, until the imagined past fits comfortably within what we see in the present sky. Orion becomes a quiet teacher, patient and luminous, showing us how the story of our home fits into the broader rhythm of stellar birth. And taken all together, the disks, the pillars, the globules, the glowing cavities and shadowed depths, the nebula and its surrounding cloud complex offer a living template for the sun's earliest history, from cocoon protostar to disk-bearing young star to a system of emerging planets. By looking outward at Orion, we are really looking inward, back through time, to the soft dawn of everything we know. The sheer number of sun-like stars and forming planetary systems within it suggests that what happened here, what happened to us, is not rare. It is a pattern repeated quietly across the galaxy, over and over, in the gentle dark. You float through the shadows now, past the small dark shapes cradling their invisible beginnings, past the softly glowing rims of globules holding the universe's most patient secrets, through the gradients and the veils and the tender, mottled zones where light gives way so gently to the dark, as the soft lantern light draws you slowly deeper into the quiet heart of creation. There's a particular peace that comes from watching something change so slowly that the change itself feels like stillness. The way a season turns, almost without announcement, until one morning the light is different and the air holds a different quality, and you realize, softly, that something has shifted. The Orion Nebula is changing in this way, has always been changing in this way. Its transformation so gradual that across any human lifetime, or any human history, it appears perfectly fixed. But if you could let your mind drift across a vaster span of time, if you could watch the nebula not as it is tonight, but as it will be across the next few million years, you would witness one of the most serene spectacles the universe offers. A stellar nursery slowly opening, its veils of gas lifting like morning mist from a valley, its stars stepping one by one into a clearer and quieter light. The first thing you would notice, in this vast and gentle time lapse, is the gas beginning to thin. The bright central cavity, already carved by the trapezium's light and winds, would widen as that radiation continues its patient work, pushing the surrounding cloud outward, expanding the open space at the nebula's heart. Filaments that now appear dense and defined would become more translucent, their edges softening, their details gradually fading. Veils that currently glow with rich emission line colors would dim and diffuse, their light spreading more thinly across a larger volume. Nothing would vanish abruptly. The change would come in measured increments, each one imperceptible on its own, the accumulated effect visible only across the deep arc of geological time. A bright nursery, slowly becoming a more transparent, more open, more quietly starlit space. As the gas thins, the radiation from Orion's hottest young stars would continue reshaping what remains, carving and smoothing the surrounding clouds, gently eroding the pillars and globules that now stand as such striking features of the nebula's interior. The tall dust columns that rise so dramatically in today's images would slowly shrink and soften, their sharp edges melting into broader, more subtle curves. Features that now stand distinct against the glowing background would dissolve, over vast spans of time, into faint traces of their former outlines. Wisps too tenuous to cast the same clear shadows, too diffuse to shelter anything within. In the long view, the nebula's intricate sculpted structures are like sandcastles under a very slow, very patient cosmic tide, each wave removing a little, changing the form without hurry, until the original shapes are finally, gently gone. As the obscuring gas clears, the young stars of Orion's cluster will become more prominent, standing out against a darker, quieter backdrop. Those that are now half hidden by glowing veils, visible but softened, their light filtered by the surrounding cloud, would emerge into a freer, cleaner radiance, shining without obstruction into the open space around them. The region would gradually shift from a cloud-dominated scene to a star-dominated one, from a place where the nebula itself is the primary visual feature to a place where the stars are. What we now perceive is a glowing wing of gas, softly illuminated by embedded suns, would become instead a scattering of bright points against the dark, a loose, luminous gathering where the nursery once blazed, its swaddling clouds finally dispersed. The young star cluster at Orion's heart would not remain tightly packed even after the gas is gone. Over tens of millions of years, the stars themselves would begin to drift apart, following their individual motions through space, their paths gradually diverging under the influence of the galaxy's broader gravitational field. What is now a dense, concentrated knot of young stars would loosen and spread, like a bright seed quietly blooming into a wide, scattered spray of light. Some stars would move to the cluster's outskirts, others would wander farther still, the whole gathering slowly thinning and relaxing into something more open, more spacious, less obviously a family, and more a loose community of travelers following paths that happen, still, to cross. While the cluster disperses and the gas clears, the protoplanetary disks around Orion's young stars would continue their own quiet evolution. The thick, hazy halos that now surround many of the youngest stars would thin and simplify, gradually losing their gas and fine dust. What were once glowing shrouds of dense material would become delicate debris disks, sparse rings of leftover fragments and grains, the last remnants of the formation process. In time, even those would fade, leaving behind mature planetary systems orbiting in clear, open space. In the imagined time-lapse, the bright haze around each star would shrink steadily inward until only the star itself remained visible, its worlds hidden in their quiet orbits, invisible but present, carrying forward the story that began in the cloud. As the disks clear, the planets that formed within them would settle into stable orbits, their long futures stretching ahead of them in the calm of open space. Any remaining dust would contribute only the faintest infrared glow, barely detectable, already thinning toward invisibility. From far away, each of these systems would appear as a simple point of starlight, its rich internal history entirely concealed. Yet every one of those points would hold a lineage leading back to the glowing pillars and globules of the nebula we see today, back to the dense filaments and protostellar cocoons, back to the very beginning of the process that also gave rise, long ago in a similar place, to the world you rest on now. The brightest, most massive stars in Orion would live their luminous lives quickly compared to their smaller companions, and even before their final stages, their changing light output and evolving winds would alter how they shape the surrounding gas. As these intense stars complete their brief, brilliant roles, their dominance over the radiation field in the region would fade. The overall illumination of what remains of the cloud would soften. The harsh ultraviolet radiation that now drives the nebula's glowing emission gradually replaced by a gentler, more muted light. In the time-lapse, Orion's inner glow would slowly mellow, its vivid colors deepening and then dimming as the most energetic sources of ionization complete their work and begin to quiet. As the massive star's influence wanes and the gas continues its long dispersal, the remaining lower mass stars, many of them similar in size and character to our own sun, would come to define the region's long-term appearance. Their light is gentler, their lives far longer, their presence in the sky calm and unhurried. What was once a dramatic nebular vista, alive with glowing gas and freshly born suns, would gradually become a tranquil field of modest stars, each one shining with the steady, reliable light of a main sequence life. The nursery's vivid youth would give way, softly and without drama, to a mature, understated beauty, a field of quiet lights where the gas once blazed. Over still longer timescales, gravitational interactions among the cluster's members would slowly reshape individual orbits, some stars drifting steadily outward with each subtle perturbation until they travel far enough to escape the group entirely. This is not a sudden departure. It is a process as gradual as the rest, grain after grain of sand, leaving a shoreline with each gentle wave, until the beach is quietly changed. The cluster would thin, then taper, and eventually its members would blend into the general background of the galactic disk, becoming indistinguishable from the countless other stars that move through the same broad region of the Milky Way. What was once a recognizable family would dissolve, gently and completely, into the larger community of the galaxy. The gas that made the nebula glow would not simply vanish in this long transformation. It would disperse into the surrounding interstellar medium, mixing its enriched material, the products of young stellar winds and the chemistry of the cloud, into the broader reservoir from which future nebulae will one day form. The atoms that now trace Orion's filaments, that glow in its pillars and soften its silhouettes, would drift across vast distances over the coming millions and billions of years, eventually finding their way into new collapsing clouds, new nurseries, new generations of stars and planets. The nebula's fading is not a loss, but a dispersal, a generous sharing of its substance with the wider cosmos, a quiet contribution to beginnings that have not yet begun. If an observer could return to our sky millions of years from now and look toward where Orion's nebula once shone, they would find the familiar fuzzy patch beneath the belt stars gone, replaced by a subtler sprinkling of points, a loose cluster where the nursery once blazed, its gas long cleared, its stars now separate and drifting. Without the glowing cloud, there would be no broad, wing-like shape to catch the casual eye. The constellation's sword would look different, quieter, its middle point no longer soft and hazy, but simply a star among stars. The change would be quiet but profound, a once busy harbor transformed into a still, open bay, its former life legible only to those who know where to look and what to read in the gentle arrangement of what remains. And on the longest timescales of all, even the stars themselves would carry the memory of Orion forward. Not in proximity, not in the shape of any visible cluster, but in their compositions and their motions, in the subtle chemical signatures that mark them as having come from the same original cloud. Careful measurements, taken by instruments far more sensitive than any we now possess, would reveal these shared origins even after the stars have wandered to opposite ends of the sky. The nursery would be preserved not in light and gas, but in the quiet, enduring journeys of its scattered children, each one a traveler carrying an invisible record of a place that no longer exists, making its way through the galaxy in a calm and unhurried drift toward whatever comes next. You rest in the stillness as the nebula breathes around you, its gas so slowly thinning, its stars so slowly stepping into clearer light, the cathedral of pillars and veils just beginning, across deep time, to open its walls to the wider dark, as the soft lantern light draws you slowly deeper into the quiet heart of creation. You have traveled a long way through this place. From the first soft lantern glow hanging in Orion's sword, through the vast luminous cloud and its layered colors, past the protoplanetary disks and their quiet cargo of future worlds, through the stellar nursery in all its phases, cocooned protostars, infant suns, patient low-mass stars, glowing pillars and shadowed globules, the warm redness of elder stars, the slow opening of the nebula's veils across deep time. You have drifted through the story of star birth from its earliest whisper to its long, unhurried unfolding. And now, in this final chapter, the journey moves further still, not backward into origins, but forward into what Orion will become, and into the deep calm of understanding what it has always been. As the nebula continues its long transformation, gas thinning, stars stepping into clearer light, pillars softening and dissolving, a subtle change in color would accompany the change in form. The vivid emission line hues that give the current nebula its striking palette, the strong greens and reds of ionized hydrogen, oxygen, and sulfur, would gradually fade as the hot young stars that power them age and as the gas itself disperses. What would remain, slowly coming to dominate the scene, would be the softer whites and yellows of many midlife stars shining in open space, their light no longer filtered and transformed by surrounding gas, but simply traveling freely into the dark. The change would be like the slow turning of seasons on a planetary scale, not a loss of beauty, but a transformation of it, from the vivid intensity of spring into something quieter, more neutral, more enduring. As the environment around Orion's planets becomes clearer, fewer dense clouds, less intervening dust, more stable radiation fields, the worlds that formed in the nebula's earlier, hazier era would find themselves in an increasingly serene setting. The complex, cloud-rich environment of their formation would give way to the long, open adulthood of a mature planetary system. A single star, steady and reliable, its light traveling unobstructed across the open space to the surfaces of its worlds. Whatever oceans and atmospheres and skies developed on those planets during formation would now be sustained in this quieter, more stable environment, evolving at their own pace, over their own vast timescales, in the calm that follows a cosmic birth. On the longest timescales, the remnant of what was once the Orion cluster would pass through different regions of the galactic disk as it orbits the center of the Milky Way, encountering new clouds, crossing different spiral arms, experiencing the tidal influences of the galaxy's large-scale structure. Each passage would bring slight adjustments to the paths of individual stars, gentle nudges from the gravitational fields of passing clouds or neighboring stellar groups. But these changes would come so slowly and be so subtle in any short span that from any human perspective the stars would appear perfectly steady, perfectly fixed. The cluster's story, and the stories of all the planetary systems it carries, will become woven into the broader, smooth motion of the galaxy itself, one quiet thread in an immense, slowly turning tapestry. When astronomers simulate Orion's future evolution, what they find is not chaos or disruption, but a clear, gentle arc. Gas densities falling steadily, stellar separations gradually increasing, nebular brightness quietly declining. These simulations trace the same trajectory observed in older, more evolved stellar regions elsewhere in the galaxy. Regions that were once as bright and active as Orion is now, and that have since settled into calmer, sparser configurations. Comparing Orion to these more mature clusters allows us to place it along this arc of development, to see where it sits in the long story of how stellar families grow and disperse. It is like holding a series of still frames from a very long, very peaceful film, each frame showing a slightly later moment in the same quiet narrative. The concept of a time-lapse of Orion also invites a particular kind of thought about generations. Not just generations of stars, but overlapping ones. Even as the current young stars age and move on, new stars may still form for a while in the remaining dense pockets of the cloud, the last few cradles persisting even as the broader nursery thins around them. Star formation will not cease all at once. It will taper gradually, like a conversation slowly winding down rather than ending mid-sentence. Its final contributions quieter and more scattered than the great burst that came before, but still real, still part of the same long process. The region's transformation is a slow diminuendo, rather than a sudden silence. The last notes of a very long, very gentle piece of music fading into the surrounding dark. In the very long future, the place in space that is now the Orion Nebula will be, to any casual observer, entirely ordinary. A quiet field of stars, perhaps a loose and barely recognizable scattering, will mark where one of the sky's most famous stellar nurseries blazed and glowed and slowly opened. Any worlds orbiting those stars will know nothing of the cloud. Their inhabitants, if they exist, if they ever come to exist, will look up at a peaceful sky and see only stars, unaware of the glowing, intricate, softly luminous cloud that once surrounded their suns, that sheltered the formation of their worlds. That was itself a part of the long story of how the galaxy keeps making new things from old gas. The nursery's most enduring legacy will not be visible. It will be present in the stars themselves, in the planets, in whatever quietly lives on them. Imagining Orion's future across millions of years turns a single, static image into a serene, unfolding story. Gas lifting like fog from a valley, stars drifting gently apart, disks fading into mature and invisible systems, the nursery becoming a quiet open cluster, and then a loose field, and then, eventually, just the galaxy, just the ordinary, beautiful background of the Milky Way. Nothing in this story happens quickly. Every change is soft, drawn out, measured in spans so vast that the word gradual barely captures them. And yet in that slowness, there is a profound sense of order, of rightness, of a universe that knows exactly what it is doing and is in no hurry to do it differently. Orion's future is a gentle journey from vivid youth into a wide, peaceful adulthood among the stars. Over millions of years, Orion's cluster will gradually disperse, its stars drifting apart under the influence of their own motions and the galaxy's wider gravitational field, scattered like quiet embers across the spiral arm. Each one will carry with it the imprint of its origin in the calm, dense clouds of Orion, a chemical signature, a velocity memory, a faint echo of the nursery encoded in its composition. The nursery itself will vanish, leaving no obvious trace in the sky, but its stars will continue, traveling as serene and solitary lights through the dark, each one a small, enduring piece of something that was once bright and shared and glowing and alive with the energy of beginnings. By mapping the positions and velocities of stars in Orion, astronomers can trace how a young cluster expands and disperses across tens of millions of years. And in doing so, they find a reflection of our own sun's story. The sun, too, likely drifted away from its original siblings, carried by its own orbital motion into a solitude it has maintained ever since. We no longer know which stars were born alongside it, which lights in the current sky were once nearby companions in the same glowing cloud. But Orion shows us how that separation unfolds, patiently, without drama, in the slow and steady way that everything in this nebula unfolds. The nursery becomes a soft guide to the sun's own quiet departure from its birth family, a reminder that every star, however solitary it appears now, was once part of something warmer and more crowded. Within the nebula's glowing face, observers across centuries have given gentle, poetic names to certain features. A dark bay cutting into the bright central region, called the fish's mouth, the surrounding wings of nebulosity spreading on either side, faint extensions reaching outward like arms opening to the dark. These named shapes turn the view into a kind of map, where each curve and shadow becomes a familiar landmark, a place to rest the eye and the mind. They remind us that the Orion Nebula has always been more than a scientific object. It has always been something that human beings look at and find beautiful and give names to and return to again and again across their lives. The way you return to a place that has always made you feel calm and small and wonderfully part of something larger than yourself. And so the journey through the Orion Nebula ends where it began, with a soft, hazy glow in the sword of a winter constellation, a gentle blur that refuses to sharpen into a star, a small and luminous patch that holds within it the entire story of how suns are born and planets form and stellar families gather and slowly, gently, peacefully disperse. From the naked eye's first uncertain glimpse to the deepest infrared portraits of hidden protostars, from the patient turning of protoplanetary disks to the long, unhurried evolution of red giants, from the sheltered darkness of globules cradling their first warm cores to the vast, slow time-lapse of a nursery opening into open space. All of it has been part of a single, continuous, deeply serene story. A story the universe tells itself, quietly and without hurry, in every corner of the galaxy where gas and gravity and time have the patience to work together. You have drifted through it all, through the lantern light and the glowing wings and the softly carved pillars, through the patient dark where new suns are still, right now, gathering their first warmth, past the elder stars and their mellowing glow and the young ones just stepping into theirs. And now at last, you rest here in the deep and luminous quiet, held gently by the same cloud that has held 1,000 new suns before you, breathing with the slow breath of the nebula itself. As the soft lantern light that first drew you and now simply surrounds you, warm and still and endlessly, gently present, and you are here, and it is enough, and everything is calm.